What is the, you have to just develop the idea. Okay, क्वेश्चंस बिल्कुल डेफिनेशन बेस्ड आएंगे, बहुत ज्यादा आपको इधर उधर करने की जरूरत नहीं है. सो लेट्स ट्राई टू डिस्कस द आइडिया और उसे आप समझने की कोशिश करो क्या हो रहा है. ओके, सो रिलेटिविस्टिक क्वांटम मैकेनिक्स is basically used when our velocity is approximately speed of light. Our velocity can be written alpha into c, and well, alpha is between 0 to 1. So obviously you have to just learn about the free particle, nothing else. So let's try to go for the free particle. We will not introduce any potential, just we will try to learn how we can write the Hamiltonian in a free particle, and then what should be the solution, what will be the final outcome of this particular formulation. So first we are just try to go for a very basic fundamental. So what is your classical Hamiltonian? The classical Hamiltonian for free particle is what? P square C square, and you can write m naught square C4 root under. Okay, this is your classical Hamiltonian. We have already learned that this type of Hamiltonian we can solve by using Taylor expansion. हम लोगों ने इसे किया था, अभी कुछ दिन पहले इसे किया था, isn't it? याद है?
Yes, sir.
क्या हमने उसमें कंक्लूजन ड्रॉ किया था? हमने उसमें कंक्लूजन ड्रॉ किया था that m naught c square is greater than p into c. ये कंक्लूजन ड्रॉ करके हमने टेलर एक्सपेंशन लिया था. एंड देन यू हैव समथिंग लाइक p square by 2m, that is your classical Hamiltonian, and you have some negative sign, and if I am not wrong, that value is 8. What is this value? याद है बताओ? 8.
1 upon m c not cube c.
What is this value? 8 upon m c square, and there is what? p to the power 4. ऐसा ही कुछ था ना? Just tell me what is this particular value? ये क्या value था?
m naught cube c square था शायद.
m naught square c cube, और क्या था value?
Yes,
What
sir.
will be that value?
Sir, mc cube था, I think, sir.
m c cube
M
कैसे
से
होगा?
तो M
Just
से-
you can
हाँ.
take the Taylor expansion, don't worry.
Okay.
मुझे लगा आपको याद होगा, but you can take Taylor expansion. That is m naught c square. So that is what? 1 plus p square c square upon m naught square c4, isn't it? And now this value is equal to what? m naught square, and here is 1 plus, and this value is what? P square by m naught square c square. And now you can just go for Taylor expansion. So what you will get? क्या मिलेगा आपको? So you have this particular thing is m naught c square, और ये पूरा का पूरा टर्म क्या होगा? 1 plus p square by m naught square c square, 1 by 2 will be there, and next term is what? Minus,
by 8.
what is this particular thing?
Minus.
p to the power 4 upon 8, and this value is what?
to the power 4
m naught 4 c to the power 4, isn't it? So this is your Hamiltonian, and if you can go for this Hamiltonian, that is m naught c square is rest mass, and you have p square upon 2 m naught.
Sir,
हाँ,
sir,
क्या हुआ?
c to the power 8 होगा.
c to the power 8 कैसे होगा?
Sir,
denominator में.
Denominator 1 by
यहाँ
8
पर?
जा. Yes,
हाँ?
sir, sir.
Yes, sir.
Why?
अच्छा, ओके ओके, आपने c square cancel
अरे
कर
p
दिया.
स्क्वायर
नहीं, sir,
किया है
सही
भाई,
Yes,
दोनों
sir.
को स्क्वायर किया है. ओके,
Sorry sir. Yes sir, sorry.
अभी तो तुरंत करवाया है, कुछ दिन पहले करवाया है भाई, क्या
Yes,
कर
sir.
रहे हो आप? है ना?
Yes, sir.
And now you have this particular thing, p to the power 4, and 1 m naught can be cancelled. So you have 8 m naught cube c square, something like this. Are you getting my point? So this is your Hamiltonian.
Yes, sir.
And if you want to write the kinetic energy of this Hamiltonian, then obviously you have to, if you want to write the kinetic energy, this is total energy. The kinetic energy is equal to the total energy minus m naught c square. And this is basically p square upon 2m naught minus p to the power 4, 8 m naught c square. So this is your kinetic energy. And now you can just calculate this thing with the help of perturbation, isn't it? Obviously हम लोगों ने एक ट्रिक प्ले किया था कि P4 के एवरेज वैल्यू को कैसे निकाल सकते हैं और बाकी सारा चीज हम लोगों ने सीखा था, isn't it? But this is not a complete solution. Unless until you are not going for perturbation, you cannot give the complete solution. So obviously this is a good try to solve the relativistic Hamiltonian, but not very satisfactory. So the first sincere try for the relativistic Hamiltonian is given by what? Klein-Gordon equation. किसके थ्रू ये डिस्कस किया जा रहा है? Klein-Gordon equation. So let's try to go for Klein-Gordon equation. वो क्या कह रहा है और किस तरह से चीजों को समझने की कोशिश कर रहा है. Okay? So let's try to go for Klein-Gordon equation, which is the first thing which will be just try to give the complete picture of relativistic quantum mechanics. Obviously, what was the idea? He just give the mind-blowing idea. What will be that idea? That idea is that he just take a Hamiltonian and that Hamiltonian as same Hamiltonian, and that is given by what? P square C square m naught square C4. This is my Hamiltonian. And what he does, he just go for square of this, and this value is can be written as P square C square plus m naught square C4, and this square can be written as minus h cut square upon d square upon dt square if we are writing in form of quantum mechanical operator. The Hamiltonian can be written in this form, isn't it? लिख सकते ना? And
Yes,
what
sir.
is your p square? Your p square is again minus h cut square and del square, and c square is also there. Del square psi plus you have m naught square C4 and psi is there. So you can take some psi. So what we are going to do, we are just trying to divide C square here such that it has dimension of length and h cut square on both sides. So when you are just going to divide it with minus h cut square and C square, then what will happen? This will be 1 upon C square d square psi upon dt square is equal to, obviously this value is what? Del square psi plus what will happen to this one? M naught square C square upon h cut square, and this negative sign will be there. Are you people comfortable?
Yes, sir.
है ना? And now the complete picture can be written as 1 upon C square d square psi upon dt square minus del square psi must be equal to, and you can take this into this direction also. So this value is equal to m naught c upon h cut whole square must be equal to what? 0. Can we write this particular thing? लिख सकते हैं ना?
Yes, sir.
And now you can see we are just developing the concept of 4 vectors, isn't it?
सर प्लस आएगा ना, प्लस आएगा, प्लस एम नॉट सी स्क्वायर, थर्ड टर्म प्लस हो जाएगी ना.
So okay, that term is what?
Plus.
This is minus, so this will be plus. Okay, yes, sorry, this will be plus. Okay, so now you look at here the concept of 4 vector. Hence you are doing the relativistic mechanics, relativistic thing. Then obviously you have to think in a 4 vectors. Okay. And now, if you can see the whole term in very careful manner, this thing is nothing but del square psi plus m naught c upon h cut whole square must be equal to what? 0. And this particular thing is identified as what? De-Lambasian. आपने EMT में पढ़ा होगा या फिर अभी पढ़ोगे, है ना? This is a very wonderful operator, and this operator is identified as De-Lambasian operator, and which is 1 upon c square d square upon dt square minus del square, and this is basically invariant under Lorentz transformation. This thing is what? Invariant under Lorentz transformation. So what we have done? We can easily solve this differential equation. Obviously, this is nothing but the partial differential equation. You can easily solve it. And this is second order differential equation in time as well as in space. What is Schrodinger wave equation? What is Schrodinger wave equation? The Schrodinger wave equation is I h cut d psi upon dt is equal to minus h cut square upon 2m del square psi plus vx psi. So the Schrodinger wave equation is actually second order in space and first order in time, isn't it? यही होता है ना? But when you are going for the CG equation, Klein-Gordon equation, this is very famous CG equation. Here you can have basically the second order in space as well as your second order in time. And this is a very wonderful wave equation, isn't it? If you are just trying to identify this thing is something equivalent to what? Your wave equation. हो रहा है क्या?
Yes, sir. Yes,
है ना?
sir.
So this is something like your wave equation. And now, if you want to go for the free particle, what will be your free particle? Free particle का solution क्या होता है? What will be psi for the free particle? Obviously, you will go a e to the power I k dot r minus omega t, isn't it? This is the solution of free particle. ऐसा ही solution होता है ना?
सर
हाँ? Yes.
सेकेंड टर्म में साई आएगा ना, मतलब m नॉट c h क्रॉस.
You can just put it psi. Don't worry. The psi is there. Okay. यहाँ भी psi आएगा. Okay. So this is some constant value. So there is nothing to do with this constant value. Are you getting my point?
यस सर.
है ना? तो ये तो कोई कांस्टेंट वैल्यू है, तो कांस्टेंट वैल्यू का कोई खास रोल यहां पर नहीं रहेगा. एंड नाउ फ्रॉम हियर, दिस इज वेरी इंटरेस्टिंग थिंग. इफ यू आर गेटिंग द एवरेज वैल्यू ऑफ एच स्क्वायर, दैट विल बी इक्विवेलेंट टू द एवरेज वैल्यू ऑफ पी स्क्वायर सी स्क्वायर प्लस, obviously this is a number, m naught square c4. And now you can think, if your particle, suppose you are considering a very different case where mass of the particle is going to 0. That is what I am talking about. If mass of a particle is 0 or rest mass is going to 0, what is meaning of that?
That is photon.
That means we are talking about photon, isn't it?
Yes,
So
sir.
we are talking about photon, and we can find the average value of energy, and this E square, if you are taking the expectation value of E, that is E square is equal to nothing, P square into C square. So from here, you can find the average value. E is nothing but average value of P into C. From here, we can easily find this particular thing. निकाल सकते हैं ना?
Yes, sir.
In this case, you can have E square का average or E ka whole square ka average, that may be the same thing and you can get this particular thing. But look at the very different thing, and which is very interesting. Suppose we are trying to make our momentum 0. Suppose I am just trying to make our momentum 0, then you have average value of E square is equal to nothing but m naught square c to the power 4, and this E has two value, and that value is equal to plus minus m naught c square. Are you getting my point? Hoga na?
Yes, sir.
Yes, sir.
And what is meaning of that? Meaning of that, obviously positive rest mass we have a full concept of positive rest mass, there is not any ambiguity. But what about negative rest mass? And here the existence of negative rest mass will tell you all about the antiparticle of some particle. So this is a very strong formulation where we can talk about the antiparticle of some particle or existence. This will just talk about the existence of antiparticle. Existence of antiparticle. This cannot be explained by Schrodinger equation or some another method. But first time Glenn Gordon tried to establish that, try to mathematically support that particular experimental event, that there must be some antiparticle existing in this particular universe. For example, electron and hole. This is one of the very nice combination of particle and antiparticle, isn't it? Where we can assume that mass of a hole is nothing but what? Negative mass, isn't it?
सर एक क्वेश्चन था सर,
बोलिए
सर जैसे मास ऑफ होल की बात आपने अभी बोली, तो सर हम वहां पे तो हम इफेक्टिव मास कंसीडर करते हैं ना?
ओहो, मैं इफेक्टिव मास की बात नहीं कर रहा हूं, मैं यहाँ पर बात कर रहा हूं मास ऑफ होल बोल या फिर पॉजिट्रॉन कह लो, नाम क्या है उससे कोई मतलब नहीं है, ठीक है? डोंट ट्राई टू मिक्स ईच एंड एवरीथिंग, एक पॉइंट पर इसको मिक्स करने की जरूरत नहीं है। आर गेटिंग माय पॉइंट? आप उसे कैसे वेरीफाई करते हो, इससे ये थोड़ी है कि वहां पर वो नहीं है।
सर मैं समझा,
आप समझ रहे हो मैं क्या बोल रहा हूँ?
नहीं सर, अभी जो आप बोले
हाँ,
कैसे वेरीफाई करते हो?
भाई मैं ये कह रहा हूं कि देयर आर n number of ways that you can exist, that you can verify that there is existence of antiparticle. Are you getting my point?
Yes, sir.
एक्सपेरिमेंटली तो वो एग्जिस्ट कर रहा है उसको। आप समझ रहे हो मैं जो बात कह रहा हूं?
Yes, sir.
उसको आप मैथमेटिकली कैसे वेरीफाई करते हो, उसके n नंबर ऑफ वे हो सकते हैं। सॉलिड स्टेट में डिफरेंट वे के थ्रू समझाया जा सकता है, यहां पर डायरेक्टली क्वांटम मैकेनिकल अप्रोच के थ्रू हाई एनर्जी लेवल पर यह देखा जा रहा है कि भाई अगर कोई भी पार्टिकल है तो उसके साथ साथ नेगेटिव मास के भी होने के चांसेस है। यहां पर मैं नेगेटिव मास को क्यों नहीं डिस्कार्ड कर रहा हूं? बिकॉज इन अ नेचर दिस टाइप ऑफ मासेज आर एग्जिस्टिंग। आर गेटिंग माई पॉइंट?
Yes, sir.
जैसे भाई कोई भी एक सी ऑफ इलेक्ट्रॉन आप ले रहे हो, you are taking C of electron. Suppose one electron is removing from this to this, another, this value have some minus mc square or m naught c square, and this value has m naught c square. So if one particle is coming from here to here, it will create some antiparticle here. Are you getting my point?
Yes, sir.
भाई अब आपके पास ये है कि E की वैल्यू प्लस एम नॉट सी स्क्वायर और माइनस एम नॉट सी स्क्वायर मैथमेटिकली दोनों आ रही है। क्या आप माइनस वाले को डिस्कार्ड करना चाहते हो कि एक्सेप्ट करना चाहते हो? बताओ।
सर माइनस को स्टार्ट ही करें।
मेरा क्वेश्चन समझ में आ रहा है? आप माइनस वाले को एक्सेप्ट करना चाहते हो या डिस्कार्ड करना चाहते हो?
डिस्कार्ड कर,
क्यों डिस्कार्ड करना चाहते हो जब एंटी पार्टिकल एग्जिस्ट करती है तो?
बट नेगेटिव मास मैथमेटिकली तो हमें नेगेटिव मास मिलता
नेगेटिव मास यहाँ तो मैथमेटिकली आ गया ना, अब क्या
है।
चाहिए?
सर,
अब कौन सा थ्योरी से तुम्हें नेगेटिव मास के बारे में बताएं?
ओके सर, एक्सेप्ट करेंगे सर।
नेगेटिव मास फिजिकली पॉसिबल हो रहा है, उसको कैसे
sir.
एक्सप्लेन किया जाए? तो ऐसे एक्सप्लेन कर सकते हैं।
ठीक सर, आ गया सर।
समझ में आ रहा है मैं जो बात कर रहा
यस सर, यस सर,
हूं? एग्जैक्टली।
100%।
देखो, आप जो भी फिजिक्स कर रहे हो, जो भी थ्योरी डेवलप कर रहे हो, यू हैव टू ऑलवेज आस्क दिस क्वेश्चन, शुड आई एक्सेप्ट इट और नॉट एक्सेप्ट इट? श्रोडिंगर वेव इक्वेशन के पास इस तरह की कोई भी पॉसिबिलिटी नहीं थी कि वहां पर आप इसे एक्सेप्ट कर पाओ। आर गेटिंग माई पॉइंट?
यस सर,
But due to this Klein-Gordon equation and finally from your Dirac equation, there are n number of ways that you can accept, yes, there is negative mass or there is existence of antiparticle. Are you getting my point?
यस सर,
And it is also important for your symmetry. ये सिमेट्री के लिए भी जरूरी है ना? जिस तरह से आपका पॉजिटिव चार्ज है, नेगेटिव चार्ज है, उसी तरह से जिस तरह से पॉजिटिव डायरेक्शन है, नेगेटिव डायरेक्शन है, जिस तरह से पॉजिटिव टाइम है, नेगेटिव टाइम, अभी तक आप नेगेटिव टाइम को एक्सेप्ट नहीं कर पा रहे हो, बट सम टाइम you can accept it. If you will go for time reversal and anything, if you will go for the 4 vectors, you have to accept the negative time. Are you getting my point?
यस सर,
तो उसी तरह से the fundamental thing is mass. तो it is very much high possibility to preserve the symmetry. If there is positive mass, there must be negative mass. Are you getting my point?
यस सर,
जैसे अभी सबसे ज्यादा कंफ्यूजन किसके ऊपर है? मास के ऊपर तो कोई कंफ्यूजन नहीं, अब टाइम के ऊपर कंफ्यूजन है कि दैट यू कैन गो ओनली इन द फॉरवर्ड डायरेक्शन, इट इज वेरी डिफिकल्ट टू गो इनटू बैकवर्ड डायरेक्शन, बट यस, if theoretically if you can travel with the speed of light, you can go into backward direction. Are you getting my point?
यस सर,
तो इस चीज को, तो आप फिजिक्स को कैसे देखते हो वो इंपॉर्टेंट है। हाँ, अभी तक इसका कोई वेरिफिकेशन नहीं हुआ है, इसी कारण हमारे कोर्स करिकुलम में या फिर डिफरेंट प्लेसेस पर हम इसको जस्टिफाई नहीं कर पा रहे हैं, इसलिए ऑलवेज वी आर टेकिंग t इज ग्रेटर देन 0, बट वंस इट इज एक्सपेरिमेंटली वेरीफाइड, there are n number of ways that you can talk about the theoretically there must be negative time or time reversal की बात कर सकते हो। yes
यस सर, थैंक यू सर।
okay, so now this is a very basic, very fundamental, okay, and if you want you can just find the current density for this particular Klein-Gordon equation. कैसे निकालोगे करंट डेंसिटी? एनीवन?
कैसे फॉर्मूले की है
हाँ,
जो आपने इनिशियली फॉर्मूला बताया
करंट डेंसिटी कैसे निकालता है?
Cos square
How you will find the current density? Huh? Current density, how you will get the probability? Basically, if I am talking about current density, that means probability current density. How you can go for this? You can just write this particular thing. This is your equation. D square psi upon dt square, that is del square psi minus m naught c upon h cut whole square psi. आप क्या करो, दोनों तरफ इसको किससे मल्टीप्लाई कर दोगे? psi star से. So just you can go for multiplying with psi star. दूसरा इक्वेशन आप लिख सकते हो, आई एम जस्ट गिविंग यू होमवर्क, जस्ट आप इसे कैलकुलेट करोगे, डी स्क्वायर साई अपॉन डी टी स्क्वायर है ना, दैट वैल्यू इज इक्वल टू डेल स्क्वायर साई स्टार माइनस एम नॉट सी अपॉन एच कट होल स्क्वायर साई स्टार। अब आप क्या करोगे, किससे मल्टीप्लाई करोगे? साई से मल्टीप्लाई करोगे। ओके, so then you will multiply with psi, then you will multiply with psi, and what you will do, you will subtract this thing such that this will be gone, Okay, and try to write it as a form of continuity equation. So आधा मैंने कर दिया, आधा आपके लिए होमवर्क देता हूं. Otherwise, I will give you solution. Don't worry, but try to do with yourself. What will be your continuity equation? You will write the whole equation as a form of del dot J plus del rho upon del T must be 0. तो इस फॉर्म में आप चीजों को लिखने की कोशिश करोगे. Are you getting my point? Yes or no?
Yes, sir.
तो
Yes.
इस फॉर्म में आप इस चीजों को लिखने की कोशिश करोगे. एंड वंस यू विल राइट दिस फॉर्म, देन यू कैन कंपेयर दिस थिंग. तो टाइम वाले को एक साथ लेकर के जाइए, जे वाले को और दिस डेल स्पेशल पार्ट को अलग लेकर के जाइए, एंड देन यू कैन फाइंड व्हाट विल बी जे एंड व्हाट विल बी योर रो. सो शुड आई गिव यू द फाइनल आंसर? Just try to do with yourself, otherwise I will give you the. So J is nothing. So J is basically defined as the same J, that is h cut upon 2I m naught, and here is psi star del psi minus psi del psi star. This is your J, but here rho is going to change, and rho is what? This is given by I upon h cut upon 2 m naught c square psi star del psi upon del t minus psi del psi star upon del t. So this is your probability density given by the Milli-Klein-Gordon. Okay, just try to do yourself. मैंने आपको हिंट दे दिया है, एक बार इसे प्रैक्टिस करो, बिकॉज इट इज वेरी इंपॉर्टेंट, है ना, कि किस तरह से आप प्रोबेबिलिटी डेंसिटी निकाल सकते हो. टुमारो आई विल डू फॉर डिराक, बिकॉज दैट इज मोर इंटरेस्टिंग. दिस इज नॉट very, this is very simple because this is second order, this is second order, so this is Hermitian, so there is not any problem. When first order of time or first order of space will come, then it will create problem. Are you getting my point?
Yes, sir.
है ना? So just try to do this thing. Otherwise, you have exactly same J, which is Schrodinger used. Schrodinger ने भी तो यही use किया था ना?
Yes, sir.
And but it has different probability density. It has new form of probability density given by what? Klein-Gordon equation. So this is the first attempt given by this Klein-Gordon. Now let's try to go for the basic understanding of Dirac. इसको मैं कल की क्लास में लेकर के जाऊंगा, है ना? But I will just give you what he have done and look at how the great mind think. एक great mind किस तरह से सोचते हैं, किस तरह से काम करते हैं, वो देखो, है ना? And obviously, Klein-Gordon, the effort of Klein-Gordon is also very awesome, outstanding. But और ये थोड़ा सा हम ये भी कर सकते हैं कि चलो, अगर Schrodinger ने नॉन रिलेटिविस्टिक में काम किया तो टाइम का फर्स्ट ऑर्डर था और स्पेस का सेकंड ऑर्डर था. There is not a big problem when you have space also second order and time also second order. Obviously, आप ज्यादा से ज्यादा आप हाई स्पीड रेंज पर काम कर रहे हो, रिलेटिविस्टिक लेकर के काम कर रहे हो, तो ये चलेगा, isn't it? But what Dirac does, he does extraordinary एफर्ट उन्होंने लगाया और एक्स्ट्राऑर्डिनरी रिजल्ट आया. डिराक की सबसे खूबसूरत बात यही थी कि ही जस्ट डू देयर हिज कैलकुलेशन इन अ वेरी एफिशिएंट वे. आइदर यू कैन जस्ट अंडरस्टैंड दिस पर्टिकुलर get bra notation that is given by the Dirac, or this particular vector notation in a quantum mechanics, and it just make our life very simple, even if it is very abstract, isn't it?
Yes,
So
sir.
now look at what Dirac have does. He just take the same thing, and what is the idea? H square is nothing but P square C square m naught square C4. This is our classical Hamiltonian. square. And what he does, he just give a very beautiful idea that if somehow I can write the whole thing in complete square, then this h will be this particular thing, isn't it?
Yes, sir.
Are you getting my point? उन्होंने ये
sir.
कहा कि भाई अगर मैं इस तरह से कुछ लिख सकूं, then I can write h as my this particular thing, this bracketed thing. Are you getting my point? So what he does, he just take this classical Hamiltonian, and obviously he just write m naught c to the power 4 is equal to c, hence p is some vector quantity. He takes some vector alpha dot p plus beta m naught c square whole square. And this is nothing but what? H square. Now, what is your h here? If somehow we can write this is equal to this, and our duty is that what is my alpha and what is my beta? This is our real challenge, that we have to find what is my alpha and what is my beta. Then obviously, what is my h? H क्या हो जाएगा बताइए?
C alpha dot
Obviously, C
dot
alpha
plus
dot
beta
P
m naught.
plus beta m naught c square. And now you can see what is your h. H can be then now your equivalent to Schrodinger wave equation. The Dirac equation can be written as a form of minus I h cat del upon del t. This is the same operator, which will be C alpha dot P plus beta m naught c square. And what is this P? This P is nothing, but you can go for minus I h cat, and I can write it in a very nice way. That value is minus I h cat del, and this is vector alpha dot del, and you can just go for psi and psi plus beta m naught c square psi. You can just go for ket also, don't worry. Yes, and now look at the beauty of this particular equation. The beauty of this particular equation is that this is not minus, no? This is plus. I h cat del psi upon del t is plus. Now look at the beauty of this particular equation is that this is first order in time and first order in space. Isn't it?
Yes, sir.
This is real beauty. You can see. What is next challenge? The next challenge is that what is the value of alpha and what is value of beta? We can figure out what are these particular value. So इसको हम जरा देखने की कोशिश करते हैं, how we can get this particular value of alpha and beta. So should I continue और फिर कल की क्लास में करना है? Just tell me.
Next class में करेंगे, sir.
हाँ?
Next class में ये करेंगे.
Next class में करना है. Okay. Don't worry.
Sir, आज थोड़ा mess था ना इसलिए.
हाँ, sorry.
Sir, वो mess closing time हो जाता है ना इसलिए.
हाँ, ठीक है. इसलिए तो मैं पूछा ना. Don't worry. Okay. So in the next class, we will just figure out what is alpha, what is beta, and then we will just try to write and try to analyze the Hamiltonian of the charged particle in an electromagnetic field. उसको हम जरा Dirac equation से solve करेंगे. And obviously, we will also try to figure it out what will be, and that the G factor, the basic concept of gyromagnetic ratio of electron कितना आता है? 2 आता है ना?
Yes, sir.
So
हाँ,
from
sir.
where it is coming, and उसे हम जरा समझने की कोशिश करेंगे with the help of Dirac equation. Okay? So
Yes, sir.
कल हम लोग इसे कंप्लीट करेंगे. Okay?
Sir, land